In this lesson, we're going to talk about limiting and excess reactants and how we can figure out which reactant is the limiting one when you have a chemical reaction and you're given amounts for both reactants. So the limiting reactant is the one that gets used up first, and so it controls how much product is going to be made, or it limits how far the reaction can proceed. And then the other reactant that is left over is the excess reactant. So how can we figure out which reactant is limiting? So let's look at a sample. If 1.35 moles of nitrogen gas reacts with 3.78 moles of hydrogen gas, which is the limiting reactant and which is an excess? And here's the reaction that's happening to form ammonia. So we've got 1.35 moles of nitrogen and 3.78 moles of hydrogen. So we have to figure out which one would be used up first. So to do this, you can choose one reactant and then use the mole ratio to calculate the number of moles of the other reactant that would be required to completely react. So if we choose nitrogen, we've got 1.35 moles of nitrogen. So we're going to use the mole ratio with moles of nitrogen on the bottom, moles of hydrogen on the top. So 1.35 times 3 gives us 4.05 moles of hydrogen. So what that means is that in order for all of our nitrogen to react, we would require 4.05 moles of hydrogen. So then you have to ask, do we have that much hydrogen? And in this case, the answer is no. Right? The question tells us we only have 3.78 moles of hydrogen, which means the hydrogen is going to run out first before the nitrogen. And hydrogen is therefore the limiting reactant, and nitrogen is an excess. So we can also solve these problems if we're given masses of the reactants. So in this sample problem, we have 2.5 grams of nitrogen gas reacting with 0.60 grams of hydrogen gas. And so again, which is the limiting reactant, which is in excess. So the first thing we need to do is convert those masses to moles. So we're going to, for nitrogen, we're going to use the molar mass of nitrogen, N2, 28.02 grams, to convert the mass to moles. So we have 0.0892 moles of nitrogen. Then we're going to do the same type of reaction for hydrogen. We have 0.60 grams of hydrogen. We're going to use the molar mass of hydrogen gas, and we find that we have 0.2970 moles of hydrogen. So now that we're at moles, we can do the same step we did in the last question. We're going to choose one of them, use the mole ratio to determine how much of the other reactant would be required to completely react. So if we choose nitrogen again, we're going to convert that to hydrogen. So this tells us that in order for all of our nitrogen to react, we would need 0.2676 moles of hydrogen. So then you compare. So this is the amount we need. We have 0.2970 moles of hydrogen, which means we have more than enough, and nitrogen is going to be the one that's going to run out first. So nitrogen is the limiting reactant, and hydrogen is in excess. So the other thing we can do with limiting reactant problems, and this is a very common question that you're going to come across, is how much product is made. So when you carry out a chemical reaction, you're going to weigh out one reactant, weigh out the other reactant, and mix them together. So in previous questions, you've been asked for figuring out how much product is made, but you were only given the amount of one of the reactants. And it was just assumed that the other one was in excess and that the one you were given was the limiting reactant. So now we're going to look at situations where the question is going to give you amounts for both reactants. So you're first going to have to determine which reactant is the limiting reactant, and then that will allow you to determine how much product will be made. Because the limiting reactant would make less product than the excess reactant would be able to make. Right? So that's kind of the idea that you're going to use to figure out how much product is made. So let's look at another sample problem. First, just with moles. So determine the number of moles of sodium chloride that would be produced from the reaction between 4.80 moles of sodium and 2.70 moles of chlorine. So we're going to determine the number of moles of product that each reactant could make. So 4.80 moles of sodium, we use the mole ratio to figure out how many moles of sodium chloride that could make. And in this case, it's a 2-to-2 ratio or a 1-to-1 ratio. So 4.80 moles of sodium could make 4.80 moles of sodium chloride. We do the same thing for chlorine. We got 2.70 moles of chlorine. We're going to convert that into the amount of sodium chloride that we can make. So in this case, we're going to multiply by 2. So if all of that chlorine reacted, it would make 5.40 moles of sodium chloride. However, all of that chlorine is not going to be able to react because the sodium is going to run out, because the sodium is only able to make 4.80 moles of sodium chloride. So you look at those two numbers and you pick the smaller one. That's the amount that's actually going to be made. And the reactant that makes that smaller amount is the limiting reactant. So sodium creates the smallest amount of product, so it is the limiting reactant. And so 4.80 moles of sodium chloride are made during this reaction. So now in our last sample problem, we're going to work with masses, which is the more common way that you would do things when you're carrying out a reaction in the lab. So we want to determine the mass of sodium chloride that would be produced from the reaction between 1.42 grams of sodium and 2.14 grams of chlorine. So what we're going to do is we're going to determine the mass of sodium chloride that could be made if each reactant reacts completely, and then pick the smallest amount. So we got 1.42 grams of sodium. We're going to convert that to moles using our molar mass of sodium. Then we're going to use the mole ratio to find out how many moles of sodium chloride are required. And then we're going to use the molar mass of sodium chloride to determine the mass of sodium chloride that could be produced if all of the sodium reacts. So if all of the sodium reacts, we're going to make 3.61 grams of sodium chloride. Now we carry out the same type of calculation for chlorine. So we've got 2.14 grams of chlorine. We're going to use the molar mass of chlorine to figure out the moles of chlorine. And then we're going to use the mole ratio to convert to moles of sodium chloride. In this case, it's 2-to-1. And then the last step is exactly the same. We're going to use the molar mass of sodium chloride to find the mass of sodium chloride that could be made. So if all of the chlorine reacts, we could make 3.53 grams of sodium chloride. So because chlorine would make less sodium chloride, that's the amount that is actually produced, and chlorine is the limiting reactant. So that's how you can solve problems where you have information about both reactants and you need to figure out which one is limiting in order to figure out how much product is created.